All right, guys, this is topic 8, student activity sheet 6, linear inequalities in two variables. Okay, the other day we did one variable. Two variable means that now we're going to have an x and a y. Okay, let's take a look at this first problem here. So suppose you and some friends go to the movies and buy some snacks. The snack bar charges $2 for a box of candy and $6 for the combo. Which the combo involves a medium drink and popcorn. Write an expression that's no equal sign, no inequality sign there, guys, just an expression that represents the total amount we could spend at the snack bar. Okay, the big thing here, guys, to take note is that we don't know how many boxes of candy we're going to get. We don't know how many combos we're going to buy. What we do know is that boxes of candy cost $2 a piece and combos cost $6 a piece. So what I'm going to do here is I'm going to show I can spend $2 per box of candy and $6 per combo. Okay. And then again, an expression, no equal sign, no inequality symbol. Now jump down here to number 2. Same exact situation here, guys. We got our candy and our combos, but it says that we have $12 left to spend after we buy our tickets. Okay. We have $12 left to spend. They want us to use our expression that we made up here to write an inequality that indicates that we would get change from our snack bar purchase. Guys, what that means to get change, that means that I cannot spend all $12. I can spend $11.99, but I cannot spend all 12. What that means is that I have to spend less than that. So I'm going to take my expression and I'm saying I have to spend less than $12. Number 3, they want us to determine if 5-1 is a solution to this inequality. What this is, guys, this is an ordered pair. This is a point on a graph, 5, 1, meaning over 5, up 1, put a dot. The 5 is my x, the y is a 1. All we need to do is substitute, plug it in, the 5 into the x spot and the 1 into the y spot. Okay, so when I do this, it now says 2 times 5 plus 6 times 1 has to be less than 12. I get 10 plus 6 is less than 12. 16 less than 12. I don't know what world you guys are in, but in my world, that is not true. That means that the 0.51 is not a solution, okay? A true statement, if it was true, that means it would be a solution. A false statement means that it is not a solution. Okay, turn the page. So I wrote the expression up here again because we're going to keep using it. We need to determine if buying 2 boxes of candy and 1 combo would satisfy the problem. When it says satisfy the problem, means is it true or not? Okay, is it true? So with this, my 2 boxes of candy, that 2 is now going to be my x and the 1 would be my y. This would be like if I plugged in the number, the 0.2 comma 1. Same thing. So 2 times 2 plus 6 times 1 has to be less than 12. 4 plus 6 is less than 12. 10 is less than 12. That is true. That means that that is a solution. Okay. We can buy 2 boxes of candy and 1 combo and still have money left. Okay. So what we did here, guys, number 5, which of the given ordered pairs are solutions to this inequality? So with this, what I just showed here was plugging in to this function up here. 2 times 3 plus 6 times 2. 2 times 0 plus 6 times 1, so on and so forth. And what I needed to know, what I noted underneath, is what each of those equaled. Okay? And I know that it has to be less than 12. That was part of my rule up here. And so I stated that after doing this, the 0.01, 6, -2, -4, and 5, 0 are solutions. It comes out to be less than $12. But the 0.32 and 9, -1 comes out to be more than 12. So now, guys, for number 6, they want us to graph this line. graph the line and then label the solutions with the letter T and then the non-solutions with the letter F. Okay, so what I did here is I went ahead and I labeled this. Okay, I drew my line. And for you guys to see, I went ahead, I got the Y alone. I put it in slope-intercept form. There was another way you could do it too by finding intercepts. But for now, this is what I did. And I ended up with y equals 2 minus 1 over 3x. If I could rewrite that for you, it would say y equals negative 1 over 3x plus 2. Same thing. Okay, same equations. With that, what I want to take note of here is I used a dotted line. Why did I use a dotted line? Okay, because if you take note up here, we had an inequality symbol. So really, in these, instead of these being equal signs, what these need to actually be are inequality symbols. Less than, less than, less than. Okay? With that, again, I used a dotted line because I don't want us to think that we can equal this amount. So what I did is I took each of these points that were true, that were solutions, plotted them, marked them with a T. Each of the ones that were false, not solutions, I marked with an F. Okay. And what I noticed that all solutions marked with a T fall below the line. All solutions fall under the line. Okay. So then number 7, how could we modify our graph from question 6 to show all the ordered pairs that make the inequality true? Okay. And what that means is that we are going to shade the area where our solutions are true. What this means here is that from this line, I could tell you whether I knew the problem or not, that anything below this line would be a solution. Anything that falls on the line or above it would not be a solution. Okay, so now number 8, they want us to write the equation of the graph here. So a couple things that I noticed. I just want to start with the line. Okay, I need to put it into slope-intercept form. And what I notice is that my intercept is 2. That's where I got that plus 2 from. And then my slope has a rise of 1, a run of 2. So I got 1 over 2x. The second thing I need to do is look at my shading. Okay, I see it's shading below. Below means that I'm going to use the y is less than. Now, I chose just the less than and not the one with the or equal to line underneath because it is a dotted line. Okay. And then I'm going to combine the symbol with my equation and I get y is less than 1 over 2x plus 2. Okay. You can go through if you want on Agile Minds and work through this problem. And if you wanted to, you could do B also, but we're not going to do that today. Let's jump to the back. I know some of these problems, they said reinforce, but I want to do one with you guys. I'm going to do number 10 with you guys, and then we will do, you could do number 11 in class. But there's some rules that I want you guys to take down, okay? Rule number 1, okay? To determine which type of line we're going to use. If it says greater than or equal than, we're going to use the dashed dotted line. If it has the or equal to symbol, we're going to use a solid line, okay? This is equivalent to our open circles and closed circles that we did on the number line, okay? Now, my shading, okay? My shading, guys, this is equivalent to when we drew the arrows one way or the other. If it was a less than, we drew the arrow that way. If it was a greater than, we drew the arrows to the right, okay? Same thing here. If it's less than, we're going to shade down. If it's greater than, we shade up. So the first thing I'm going to do, I look at this problem here, guys, and you can graph it like this, but I like to put them in slope-intercept form. So all I need to do to get this y by itself is to move this 1x to the other side. I'm going to subtract it, And then I'm going to rewrite it to say y is greater than or equal to negative 1x plus 6. Okay. First thing I'm going to take note, because of my or equal to line underneath, I'm going to use a solid line. And because it says y is greater than, from that line, I'm going to shade up. Okay. So graph the line. My intercept is 6. I'm going to go down 1, positive 1. I could also go up 1, negative 1. They're the same thing. Solid line. And then I said shade up. So from any point on that graph, guys, you can draw lines straight up. And that tells you that we're going to shade this side of the graph. Shade lightly. Shade lightly. Okay. Another way that your teacher may prefer you to do also is to pick a point that's not on the line. I always like to choose 0, 0. Okay. And we could plug it into this equation. Okay. If it's true, equals shade that side. If it's not true, shade other side of the line. So when I pick the point that's not 0, 0, I'm going to plug it in. 0 plus 0 has to be greater than or equal to 6. Well, guys, when I do that, 0 is greater than or equal to 6. No, that's not true. So I'm not going to shade this side of the line. I'm going to shade the top side. Okay. Go ahead and do question number 11 in class with your teacher. Have a great day. Bye.